All right, so this next section of chapter 11 is going to be on colligative properties of solutions. And so colligative properties are properties that only depend on the concentration of solutes. It doesn't matter what the solute is. It could be NaCl, it could be rubbing alcohol. It doesn't matter. And so vapor pressure, that did matter. It did matter whether we were dissolving something like salt or something like rubbing alcohol that had its own vapor pressure. That would give us a different result. So that was not a colligative property, but these are going to be things like boiling point, freezing point, also known as melting point, same thing, just depends on if you're going one way or the other, but same temperature. And osmotic pressure, which might be a new idea to you. If you've taken biology, you've definitely seen osmotic pressure, but otherwise, I'll be introducing it, but don't worry, I'll talk about what that is. We've talked about boiling points, we talked about freezing and melting points, but now we're going to talk about how adding stuff to the solution moves where that freezing point or boiling point is. But before we do that, one last thing to talk about on this screen, and that is a new unit of concentration. I know you felt like you really had something lacking in your life, maybe you've been stuck at home, and now you have your new friend to keep you company, molality. And so it's a lot like molarity, but just different enough to really screw with your mind. And so molarity was big capital M, molality is little m, and you go, I thought that was meters. And the answer is, yeah, well, now you gotta figure it out by context. So are you talking about how much stuff there is? You're probably not gonna be like, oh yeah, there's about 3 meters of salt in that bag. No, you'd be like, oh, you know, that solution's probably like 3 molal, not molar, molal, that's how we shorten it. And it's a little bit different. So it is still moles of solute, but we're not dividing by liters of solution anymore. Now we're dividing by the mass of solvent. Not even the whole solution, just the solvent. And so it's not a unit of concentration. It's a lot like molarity. Like I said, it's close enough that it'll trip you up. And I'm not doing this, you know, to be entirely cruel. I have my reasons. It's going to be very important for boiling point and freezing point changes as we start dissolving stuff into solutions. So we got to understand this unit. And so a quick example here, you'll never guess what I dissolve in water. That's right, oh boy. You take an entire year of the chemistry of salt if you take the whole class with me. But we got 500 grams of water. We're going to dissolve 100 grams of sodium chloride into it. And we're going to figure out what the molality is. And so to do that, I got to take my grams of H2O and I've got to convert it to kilograms because this is going to be in kilograms. Let me make a note there. I almost forgot. This is mass of solvent in kilograms. Whew, that was close. So we can't do grams. It's going to be moles per kilogram. That's always the unit of molality. So we do that. We just divide by 1,000. Boom. It's half a kilogram. All right. Now we have 100 grams of NaCl. We do this the old-fashioned, what was it, chapter 2, I think, way. And we just divide by the molar mass, and we get number of moles. So it's a solid. Put it on a balance. I got 100 grams. Divide by the molar mass. Done with that. And so molality, we've got kilograms of solvent, we got moles of solute. What do we do with them? That's right, the cunning art of division. All right, so we go moles over kilograms. I forgot to write my K there. Shame on me. Maybe I could figure out a way to just superimpose a K there, like Superman's not mustache or something, I don't know. All right, and we just carry it through, and so we get 3.422 molal. That's the solution. 3.422 molal. Say that a few times to yourself. It's a very fun word, molal. It just rolls right off the tongue. And that's all there is to it. And we're gonna lean on this unit a lot in the next 2 videos. So that's why I talked about it. So we'll do a video on what happens to the boiling point, a video on what happens to the melting point or freezing point, same thing. And what osmotic pressure is and how it changes with solutes. And the good news is osmotic pressure actually uses good old molarity. The bad news is these don't, and so you got to remember context. So enjoy. All right, so we'll get rolling on boiling point next.